Hi, my name is Dylan. I'm from Singapore. All satellites operate on electricity, and my role is to design an electric power system to harvest, store, and deliver electrical energy to the entire satellite throughout its mission under required specifications. Unlike on the ground, there are extremely limited ways to obtain energy in significant quantities in space. The most common method is to use solar panels to convert energy emitted by the sun into electrical energy. However, depending on the satellite's altitude and location, the satellite might not always see the sun. Thus, we need a way to store energy which can be used to power the satellite when in the dark. One of the few possible methods we use to store energy is to store them in chemical batteries, just like those in phones. Our satellite, however, uses batteries of somewhat different chemistry and of higher quality due to the harsh conditions of space and its mission requirements. Some other key components of the electric power system include the microcontroller, voltage converters, and battery charger. I like to work on space systems because of the thrill and tension of building systems that need to work well without being able to be serviced once deployed.
Hello, I'm Anirudh. Since high school, I wanted to be an inventor and make some cool stuff. I studied real hard and got accepted in the Indian Institute of Technology, among the best universities in India, for a bachelor's degree in mechanical engineering. In my first year, I was introduced to manufacturing technology, and I realized that's what I had been looking for all this time, to learn how to make cool stuff. After my bachelor's, I wanted to learn more about manufacturing and automation, to make cool stuff on an industrial scale. So I applied to the best ranked universities in the world and got a master's degree program in mechanical engineering specializing in manufacturing and automation in the National University of Singapore, NUS. It was the best ranked university in the world at that time that offered manufacturing and automation. My job here at Galamat Aerospace is about building the structure, the solar mechanisms, anything that has a physical presence, the combination and compilation, assembly of all the parts that are involved in making the complicated machinery that is a satellite. Any mount, any fastener, any mechanism, you name it, I make it. What types of materials do I use? The most common material used for most of the parts in a satellite would be aerospace grade aluminium. For other stuff, I use some glass, some exotic coatings for radiation protection and other stuff, steel for some of the higher strength parts, copper for higher conductivity, for wiring as well as thermal management. Sometimes we use higher density materials to make reaction wheels where we need to have a lot of mass in a small space.
Hey, I'm Warren, and I'm the guy in charge of making small rockets called thrusters. I come from an aerospace engineering background from the Singapore Institute of Technology. The thrusters I make at Galamat help satellites perform maneuvers to avoid danger. It's like changing lanes to avoid crashes. Typically, thrusters use propellants like xenon or krypton, and the thruster component itself uses materials like aluminum and titanium. My job is important because space is like driving in an oncoming lane. One wrong move and it's game over. As a child, I always believed humanity can one day travel freely between planets, and I want to become the person that's remembered as the father of space travel. So working at Galamat here has been a major step forward in making my dreams come true.
Hello future scientists and explorers, I'm Himaja Vechalapu and I work as a spacecraft communication engineer at Galamat Aerospace. My job is all about making sure that when spaceships venture into space, they can talk to each other and with us back on Earth. Imagine you have a walkie-talkies to chat with your friends while playing outside. Well, think of me as a person who designs those walkie-talkies for spaceships and satellites in the vastness of space. You see, in space, there is no Wi-Fi or cell towers like we have on Earth. So I create special systems and antennas to help spaceships send and receive signals. It's like being the space messenger, ensuring that the astronauts and satellites can share information, pictures, and import data. But what inspired me to become a communication engineer in the space industry? Well, it's the incredible mysteries of the universe, a deep love for technology, and the burning curiosity that led me here. It's like solving a never-ending cosmic puzzle, and I love every moment of it.
So as you can tell, a spacecraft or a satellite is a complex system. It involves many subsystems that my teammates have talked about. So often you need to come together to think about how the different subsystems interface with one another. So we have a space systems engineer whose job is to make sure that the EPS works well with the comms, that the thruster is working with the ADCS properly if it is part of that system, or making sure that the solar panels are able to point to the right direction in space. All these things need to come together properly before it is launched. So that's the job of the space systems engineer. As a space systems engineer, the main things you need to understand go across all the subsystems. Therefore, you need to be someone who understands concepts from chemistry, concepts from physics, concepts from mechanical engineering, and so on. So it needs someone who likes to essentially explore many areas in technology.
The process of building a satellite starts with a conceptual and mathematical model. This model is on a computer. We design the satellite on a computer so that we can see how things interact with each other, how they're connected, how much mass the satellite will have, and how to control temperature and currents and power and so on. After this computer modeling, we build a prototype.
Finally, we assemble the satellite that will go to space. This satellite is assembled in a very clean environment. At Galamat, we have an ISO 5 standard clean room, which is a very high quality kind of clean room. Before we go inside, we have to dress up in special clothing, clean gown, clean shoes, and a hairnet to cover the hair. We also get a thorough clean using an air shower which blows away any dirt or particles that might contaminate our satellite. Once inside the clean room, we can assemble the satellite. We use different tools depending on what we are assembling. We will then take the satellites for many tests. These tests give the satellite the experience of launch and of being in space environment. Only after the satellite has passed all the tests can we then send it to a launcher. The launcher will use a huge rocket to send our satellite into space. Once it arrives in space, satellites can do whatever it is designed to do. For example, it could start broadcasting TV shows to your satellite dish.
I hope that this video has given you an overview of one, the different parts, the different subsystems of a satellite, as well as the different skills required in building a satellite. 2, I hope we've given you an overview, a good enough overview of the process of building a satellite, going from a design in our heads, on our computers, all the way to prototypes in the lab, as well as full assemblies in the cleanroom environment. We, as Galamat Aerospace, are one of the very few companies in the world that can go from design all the way to build of a satellite. So for those of you interested in having hands-on experience in building spacecraft, we welcome you to join our team here in Singapore. You could join physically here as well as remotely. We look forward to welcoming you to be part of the Galamat team.